towards the part 3. Part 3 is fixed tension with different frequencies. Now, initially what we did is that we fixed the frequency to 60 hertz and we changed the tension by increasing or decreasing the masses. In this part, we are going to fix the tension. That is, we are going to decrease or increase the frequency. And because of the change of the frequency, the number of antinodes will be changed. So now slowly increase the frequency of the generator, starting from the 0 hertz and increase carefully. And once you reach such a frequency, fine tune it with the frequency adjustment, complete the observation and fill this table. This is for the one segment. Then we are going to increase the frequency. And at certain frequency, we get the 2 segments. Similarly, at a certain frequency, we get 3 segments. So you have to write the number of antinodes. For example, in the first case, this is 1. In the second case, this is 2. In the third case, these are 3. And you have to mention that for one antinode, what was the frequency? For the second antinode, what was the frequency? And for the third antinode, what was the frequency? Also, you have to measure the wavelength. And you already know that how can you calculate to measure the wavelength? You have the meter rod, and you know that in one wavelength, there are 2 loops or 2 segments. If there is 1 segment, it means it is half wavelength. So do your calculations according to this. And once you have the value of the frequency and wavelength, multiply both of them in the last column. Moving towards questions 11, 12, 13, and 14 of part 3, that is fixed tension with different frequencies. Question 11. The last column is the product of frequency times wavelength, that is F lambda. What SI units does this frequency have? You know what's the unit of frequency? This is cycles per time. And what's the wavelength? It's meter per cycles. Or you may say that frequency is the reciprocal of time period, that is 1 over second, and lambda can be presented as meter. So what do you conclude? That what this quantity is. Also, you should have the formula in your mind that V equals F lambda. What are the units of V? Question 12. What kinds of quantities have the same units as does the frequency times wavelength? Once you get the units of the frequency and the wavelength, then you can tell that what other quantities have the same units. Question 13. Is the quantity F lambda approximately the same for all the standing waves? Check from your table 10 the values of F lambda for different antinodes and see whether this product F lambda is constant or not. Based on the values in the last column, calculate the average speed of the waves in the string. So if you have taken 3 readings, that is 1 for 1 loop, for 2 loop, for 3 loops, you have 3 values of F lambda. So how can you calculate the average of these 3 values? You plus all these 3 values and divide it by 3. So this is how you will get the value for the average speed. Part 3, fixed tension with different frequencies. Question 15. Look at the frequencies you found that give good standing waves. Do you see a pattern for these values? What relationship do you find between the frequency and the number of antinodes? So first of all, remind this first figure, which we discussed earlier, that if we have 1 segment, our frequency was V by 2L. If we had 2 segments, our frequency was 2F1, and we had 3 segments, our frequency was 3F1. But look at your table, look at your values which have been added to your table and check That is there any relationship between F1, F2, and F3? Are they similar to this relationship which we have already mentioned in this figure? And is there any relationship between the frequency and the number of antinodes? You can think that frequency is related to the wavelength. Frequency is inversely proportional to wavelength, and wavelength is inversely proportional to antinodes. So what would be the relationship of frequency and the antinodes? Or you may think that for frequency F1, your number of segment or number of antinode was 1. For F2, where there were 2 loops, number of segment or the antinodes were 2. When the antinodes were 3, you have the frequency 3, F3. So from the values, deduce what's the relationship between the frequency and the antinodes. Question 16. Look at the wavelengths you found to give good standing waves. Do you see a pattern for these values? Express the wavelength in terms of the length of the string and the number of antinodes. As we already discussed, that standing waves generate on specific frequencies or on specific wavelength, which is known as the harmonics. So this question asks you that is there any relationship between all wavelengths? You have lambda 1 for 1 loop, you have lambda 2 for 2 loops, you have lambda 3 for 3 loops. So just check their values and see are they multiples of each other or not, and how you can express them in terms of the length of the string. You know that when there is 1 loop, lambda is equals to 2L. When there occurs 2 loops, then lambda becomes L. And when there are 3 loops, lambda becomes 2 by 3L. So from these values, how can you conclude that the relationship between the wavelength and the relationship between the number of the antinodes?